Hello everyone, this is a new ControlNet for Flux One Dev. We're going to check out how to use this ControlNet model for image upscale in ComfyUI. First of all, we are going through the model information and try out some image generation in ComfyUI. This ControlNet model is available on Hugging Face right now. As you can see, there are descriptions on the page. It's using the Flux One Dev ControlNet models, a similar concept to upsizing your low-resolution images with this ControlNet. What it does is directly use the diffuser libraries, so you're able to use it like a normal ControlNet and plug it into any Flux text-to-image or image-to-image workflow to generate upscaled images. The beauty of this is that it doesn't require any upscaler models or the ultimate upscale SD upscale nodes to process this ControlNet upscale. It's also able to retain the details of the original image. It won't generate different details or add artifacts to your upscaled image. So let's check it out. First, you're going to download the model file here. Click on the Files and Versions tab. You'll see the Diffusion PyTorch models save tensor files. When you download this 3.58 gigabyte file, you need to rename it. Typically, I just rename it to match the title of the model name. After you download it, place it in the Models folder in the ControlNet subfolder, just like we usually do for ControlNet models. As you can see, I've downloaded it into the ControlNet subfolder. I've created another subfolder inside called Flux to store our ControlNet, like we do for other ControlNets as well. By choosing this Flux ControlNet Upscaler in the Load ControlNet Models node, we're able to use it like a normal upscaler. For the Apply ControlNet, we're now able to use the normal ControlNet Advanced Custom nodes. Previously, we talked about Flux ControlNet. For example, the Union Pro is an all-in-one ControlNet model. As you can see in my previous videos, I paused the screens and showed you that we were going to use the ControlNet Apply for SD3. Now, we don't need to use that for the latest versions of ComfyUI. We can just use a normal Apply ControlNet Advanced. We need the advanced version for this because we have to load the VAE within these ControlNet custom nodes, and also we're not going to connect any preprocessors to the image input. Before, we talked about tile upscales and other kinds of upscales. We needed to connect the preprocessors for processing the ControlNet image. But here, as you can see, I'm directly connecting it with the load image node. So I have the same image that I tested in the last video of the ControlNet Union Pro, and we're going to check this one out as well. On the top here, it's just like the previous workflow that I did for Flux ControlNet, except I've changed the Apply ControlNet for these nodes here, and also changed the text clip input text prompt using Florence 2. So Florence 2 is going to generate a large detailed captioning that's applied to the text prompt here. This ControlNet Upscaler model uses a synthetic complex data degradation schema to train. So it's able to take up the text prompt like Flux T5, kind of T5 clip text prompt as well. We can just use Florence 2 to automatically plug that into the text prompt input. Then basically, this is a very normal workflow sampler and VAE decoder as well. We have another node here below. I've created the image resize using the JK node, get the image size and count, and then I pass the width and height of both dimensions values. I pass that to a simple math node here, so we'll get the width and height of this loaded image. We pass that to the simple math as 8 values, and we'll multiply by how many times we input in this integer value. Let me change the color of that. We have to remember to change these values whenever we want to upscale. By default, I'll put that as 2, so 2 times whatever we input for the original image dimensions, or you can use 3 times or 4 times. It depends on how much you want to upscale. Basically, that's it for the resize image part, and we'll pass the image output here to the VAE decoder. So it acts like an image-to-image processing here, but then we're getting the enlarged size of the image. We haven't enhanced the colorations, etc. here during this process. We've only upscaled the dimensions. So we put the ControlNet to work here, and the ControlNet is taking the image from the original source image, which hasn't had any resizing done on this image data. We pass that original dimension size image data to the ControlNet here. Once we have everything, we'll generate a large image result like this. So let's put that side by side for comparison. Then you'll see the details haven't changed too much within the upscaled image. Here, as you can see, although this image is kind of okay, the colorations, etc., it's still blurry. The dimensions are in, it was generated, this original image, in SD 1.5, and after that we have another upscaled size image. As you can see, there are lots of pixels that still aren't showing the details in the source image. We have a lot of sharpened edges and everything. The hair is refined as well and look nice. We got even more details on the face wrinkles. After we use the Flux models to generate an image and we're able to make it become more detailed and add the realism styles, because I've used the realism styles Laura before that. If you don't want the realism style Laura, you can bypass this or just use whatever Laura you want to. So, that's a very quick video demo. Let's try another one that we can do together here. Let's say I have a very small size image. And this is from one of the search results in Google. It's going to be very large blurry pixels. We're going to upscale this image and see. Let's say we're going to upscale that 3 times for this image. It will approximately generate this result for the upscale size after we do that upscaler. So we don't need to do any text prompt. Florence 2 will help us make that happen. We just click run and it will start processing the text prompt of what we need for this generation. Going to the command prompt window, as you can see, it starts loading. When you see Flux ControlNet here, that means you've successfully loaded the ControlNet Flux Upscaler models and started processing 30 steps. I like to set it a little higher, and it doesn't consume too much time in this case because there aren't too many components loading in this workflow. I'm using the GGUF Flux models. The quantization of GGUF helps a lot with the loading speed and picking up every data from the start, loading these checkpoints, and passing all the model data in the case sampler. So there we have the upscaler, and as you can see, the face is a little changed from the source image. If that happens, this is what you can do. This is from an image of Megan Fox, and this upscaled image, although the colorations of the clothing and the pattern are the same, the face doesn't look the same. So in this case, we might need to do some tricks to restore the face. For example, you can use face swap method, the simplest way to restore the face. Or you can, from here in the case sampler, lower the denoise because this acts as an image-to-image method. From the VAE encode, pass the image data here from the resized image. Let's say we can try that, set it to 0.35 in the denoise settings, and see how that goes. So here's the generated result using denoise 0.3. Again, the colorations, everything doesn't change too much, but then we can have kind of the closest face outlook of the main character here. But if you want the best output performance from this upscaler, you might want to use denoise at 1.0 and use any face restore method. If this case happens for a character like that, if you have a landscape image, then you don't need to do any of that to take care of the face restoration of the character in the image. So let's try other examples here. We'll try landscape examples and see. For example, like this image, it's a very small size dimension image. It was taken years ago when the diffusion models were starting in the market. And then I played around with some image generator. Somehow I got this image, and the dimensions of that are just kept at 512 dimensions. Let's see if we can upscale this and also add more details for the landscape and the water as well. Hopefully there's something that will surprise me this time. Let's upscale this to 6 times and see how that goes. Okay, so we got the result here, and it looks like this original image, like an oil painting, and we got the upscaled image of that. As you can see, it's still retaining those painting styles of the source image here, but then we have upscaled that 6 times. I can see that this ControlNet concept is similar to what we used to run with the tile upscales because it doesn't add on any artifacts, for example, sharpening those colorations. Some upscale models will do a lot more color enhancement on certain objects, or like the ultra sharp, it will be adding a lot of artifacts on the edge of every object as well. But for the upscale ControlNet, I think this is going to just upscale the size of that and keep everything the same as the original image. For example, like this one, we can see the trees right here. I zoomed in too close, but in the source image here, it's the same trees that we see in this image. But then it hasn't added any coloration artifacts on that. It's just based on the size of the image to upscale that, enlarging it. So you'll have to do something else if you want to enhance the color of that. Maybe you can use auto adjust like what I recently like to use, like the auto contrast as well, and auto adjust V2. That's going to help you do any contrast, brightness, etc. for the image. I haven't tested yet. I just downloaded this ControlNet model today. We'll see how that works and how we can use this collaborating with any color enhancer custom nodes to make an upscaled image look even better. This is kind of a brief idea going through, and it works using a simple ControlNet like this, and we're able to upscale the image without any deformations or different image noise injecting into our generated result. Sometimes when you use the ultimate upscales, like the node ultimate SD upscale, you'll have to use again the ControlNet tile. Pass that through the positive and negative conditioning to make sure that the image is the same, exactly the same shape and form as the input image. And if you're not having those ControlNet in between the process, you'll have some random or something that looks different with the upscaled image and the original image. But then by just using the ControlNet upscalers here, it gives us more convenience, like a lazy way to just add the ControlNet here, and then we can upscale that without too much processing stuff going on in between. So there you go. We have the ControlNet upscale for Flux, and this is very easy and handy to install and implement in any existing Flux workflow, just like how I did here. All you have to do is resize your image, pass that into the VAE encoding, and you're good to go. So that's it for this video, and I'll see you on the next one. And have a nice day. See ya.